Okay, in this video we consider the one-way analysis of variance, or what is typically called the one-way ANOVA. So this is a pretty straightforward test. Recall that with the independent sample t-test, this is a between subjects test, and we were comparing two groups. So for the independent sample t-test, you had one independent variable with two levels, or two groups. Okay, so that's as many groups as you can have with that type of test. Two groups and only two groups, no more, no less. So if you want to compare more than two groups, you have to use a one-way ANOVA. So the one-way ANOVA can be a between subjects test or a within subjects test. This example here is a between subjects test. So recall that each participant belongs to one and only one group. Each participant is tested once. So what that means is we have the one-way ANOVA is going to be used when you have one independent variable with at least three levels. You can have more than three levels. You could have 4 groups or 5 groups or 6 groups that you're comparing, but you have to have at least 3 groups to run the one-way ANOVA. Okay? And similar to the t-test, your data is going to be continuous in nature. This is going to be a scaled variable in SPSS. So let's take a look at our example, and we are going to continue with the example of the effect of the beta blocker drug on post-traumatic stress. Okay, so this is the kind of same storyline that we've used for the 3 t-tests, and we're going to continue with this. So the psychologist supervisors are convinced the drug is worth further study, so they give her $10 million to start clinical trials with returning veterans. She now wants to expand her study to determine the drug's long-term effectiveness. So what she does is she's got 30 subjects here. Okay, we have group 1 who's been taking the drug for a month. We have group 2 who's been taking the drug for 6 months, and we have group 3 who's been taking the drug for 1 year. And the question remains the same: does the drug have a significant effect on traumatic memories? More specifically, what are the long-term effects of the drug? Does it hold over time? So you can see that conceptually, the one-way ANOVA is taking the mean of this group and comparing it to the mean of this group and of this group. So there's a comparison between group 1 and group 2, group 1 and group 3, and group 2 and group 3. And that will become more clear as we go through the example. So let's go to the data. Okay, you're going to set this up almost exactly like you did the independent sample t-test. You need a grouping variable, and you need a column with the scores of the participants. So if we go to variable view, here's our grouping variable, and I labeled the I put in the value labels. 1 equals 1 month, 2 equals 6 months, and 3 equals 1 year. So those are our 3 groups that we're comparing. And this is a nominal variable. And then we have our scores, which is a scaled variable. So again, this should be review for you, but all of these ones here, this is telling the computer that these people belong to group 1. And we've defined the value labels, so the computer knows that people in group 1 have been taking the drug for a month, and then here are their scores. So our first case here, this person belongs to the 1 month group, and their score is a 6 on the scale. Okay, same for the people who've been taking it for 6 months. Here is their grouping variable and their score, and the same for the people who've been taking the drug for 1 year, their grouping variable and the score. Okay, so again, you set it up almost exactly like you do the independent sample t-test. With that test, we only had 2 groups, so now we have 3 groups. Okay, same thing. So to run the test, we're going to go to Analyze. We are going to go to Compare Means, and we are going to go to One-Way ANOVA. Okay, that brings up this dialog box here. And our dependent variable is obviously scores, and our factor is going to be group. Okay, we are going to click on post hoc. We are going to click on Bonferroni. And what this test will do is it will help us compare group 1 to group 2, group 1 to group 3, and group 2 to group 3. Okay, that'll become more clear in a second. But that is what we're going to check, and the significance level is 0.05. And essentially what this test does, the Bonferroni test, and there are other post hoc tests, this corrects for something that's called family-wise error rate. So we're making multiple comparisons here between group 1 and group 2, group 1 and group 3, and between group 2 and group 3. And so recall that for a single test, the probability of a type 1 error that we're willing to accept is 0.05. Well, here we are conducting multiple tests on the same data. So what the family-wise error rate does is it takes into account that we're conducting multiple tests. It takes the significance level of 0.05 and divides it by 3, because that's how many comparisons we're making. And that is the level of significance now that you have to meet in order to reject the null hypothesis. So the idea here is that if you're using the same data to conduct multiple tests, you are increasing your error of a false positive is essentially no longer 0.05, and this test corrects for that. Anyway, so that is our option we're going to select. You're going to click continue. For the options, we're going to click Descriptive Statistics, continue, and then we're going to run the test. Okay, so the first thing we want to do is look at the means. You see the mean score for the 1 month group is 6.60. The mean score, let me minimize this a little bit. The mean score for 6 months is a 3, and the mean score for the 1 year group is a 4.2. So we do have some differences among these groups. The question is, are they statistically significant? And recall that on our scale, a higher score indicates more stress and a lower score indicates less stress. So you can see that the group that had the highest stress had been taking the drug for a month. The group that had the least stress was taking it for 6 months. And in between here, we've got the 1 year group. Okay. So we scroll down to our between group test here, and this tells us that we do have a significant difference, okay, because significant, the F value is 18.9, the significance level is 0.000. That tells us that there is a significant difference somewhere amongst these groups. It doesn't tell us where. It doesn't tell us if 1 is different than 2, if 2 is different than 3, or if 1 is different than 3. Okay, the groups. It just simply tells us that there is a significant difference somewhere. Okay, and then so if we scroll down to the outcome, our post hoc tests, you'll see that these are the multiple comparisons. Right here, you're comparing group 1 to group 2, and the mean difference is 3.6, and that is statistically significant. Okay, and you see that little star right there? The mean difference is significant at the 0.05 level after correcting for family-wise error rate. Okay, so we know that there's a significant difference between the 1 month group and the 6 month group. Is there a significant difference between the 1 month group and the 1 year group? Yes. The mean difference is 2.4, and that is statistically significant. Now, if we look at the difference between the 6 month group and the 1 year group, you see that the difference is not statistically significant. Okay? And the rest of these tests are redundant because down here you're comparing 1 year to 1 month. Well, we've already done that up here, 1 month to 1 year. We already know that that's significant. I'm going to give you a second to ponder this table. Okay, so again, we found, if we go back to our means, 1 month is significantly different than 6 months, and 1 month is significantly different than 1 year. but 6 months is not significantly different than 1 year. Okay? And if you look at the direction of the means, the 6 month and the 1 year group, which are not significantly different from one another, have the lower scores, which means that over time, the effect of the drug on stress is holding. However, even though the 6 month group is not different than the 1 year group, you can see that the 1 year group scores a little bit higher. Even though the difference is not significant, it does suggest a trend such that long term the drug may be a little less effective. And that could be because maybe people are relapsing back into old habits or things like that. Okay, that's a whole nother aspect of this hypothetical study that we're not going to get into. So let's look at the results section. A one-way ANOVA was conducted to examine the long-term effectiveness of the beta blocker drug on stress. The ANOVA revealed a significant between-group effect. Okay, there's our that's the number of groups, and this is our degrees of freedom. And the F value is 18.90. The P value is 0.001. So again, remember that the overall ANOVA told us that there was a significant difference somewhere amongst these groups, and that's what I'm reporting here. Okay, the ANOVA revealed a significant between-group effect. Post hoc tests revealed that there were no significant differences between the groups that took the drug for 6 months or 1 year, and I report the means and standard deviations. However, both the 6 month and the 1 year groups demonstrated significantly less stress compared to participants who had only been taking the drug for 1 month. And I report the mean and standard deviation and also the p-value of 0.001. And these results, here's my conclusion, these results indicate that the drug has long-term benefits for reducing stress experienced by veterans. Okay, so that is a properly formatted APA answer to the problem. Okay, that's it for now. Pretty straightforward. In the next video, we're going to look at how to conduct a between subjects factorial ANOVA.